Thank you. I'm Mr. Leonard and welcome back to Mr. Leonard's Math Extravaganza. In today's webisode, we're going to continue to work with parallelograms, and specifically we're going to take a look at designing parallelograms with specific restraints, or constraints I should say, not restraints. But if you remember from our previous lesson with triangles, we're going to take some specific parameters and we're going to create these parallelograms and then see if we can make any conjectures. Again, I got my handy dandy nice handwriting up there. We're going to create two parallelograms with a base of 5 and a height of 4. So we're going to continue to work on, or build on what we worked on in the previous couple of lessons. Let's take a look. Okay, I'm going to draw out the first one here. So I know that I need a base of 5. So I'm still going to count 1, 2, 3, 4, 5. Okay, there's my base of 5, nice handy dandy little line. And I'm going to go in a diagonal this way. 1, 2, 3, 4. I'm going to put my point there and connect my line. I know that my base is 5, so I'm going to count over 5. 1, 2, 3, 4, 5. My little line there. And draw my line on the side. And connect my parallelogram. So again, I'm going to label this so that I can see it. I know that the base was 5, and that if I was going to draw the height in here, and even if I draw a little line down here, the height is going to be 4. Now an important thing to remember, when drawing out my height in here, and again we would have our right angle on the side there, the height is 4. This side is not necessarily 4. Again, so don't get that confused when working with area and perimeter up here. If I were to take this line and then make it straight, it'd be higher than 4. So again, the height would on the inside of the parallelogram there. Our base again, where the parallelogram was sitting there on the bottom, which was 5. So keep that in mind when working with area and perimeter. What I'd like you to do is I'd like you to draw out a different parallelogram using a base of 5 and a height of 4. I'd then like you to attempt to find the area and perimeter of both and see what conjectures you can make about both. So again, I know you're ready to go with that grid paper, pencil, ruler, maybe a marker too. Go ahead and pause this video and we'll see what you come up with. Okay, now there are several different examples you could use for parallelograms. So yours that you drew at home might look different than the one I'm going to draw over here. But I'm going to go 1, 2, 3, 4, 5 across there. And I'm going to go on a diagonal this way. 1, 2, 3, 4. I'm going to use my handy dandy ruler here. Count over 5. 1, 2, 3, 4, 5. And connect that line. And then connect this line. So that now I have my parallelogram. I'm going to label it 5 here. I'm going to draw my line down the middle here to label my height as 4 on the side there. And so, I now have two parallelograms up here that have a base of 5 and the height of 4. Now, we're going to look inside here and attempt to figure out, well, how can we find the area of each one of these? Well, as we've been learning with our formulas in here, we know that base times height is going to give us the area of this parallelogram. So if I were to do 5 times 4, that's going to give me an area which is equal to 20 centimeters squared. I would do the same thing on this side. The area is going to equal 20 centimeters squared. So the first conjecture I can make is that with the same base and the same height, two parallelograms might look different, but they're going to have the same area. Now if I were to take a look at each one of these sides for the perimeter, I'm going to use my ruler to measure this out, and I'm going to use centimeters on here. So let's see, I got my bottom here, and if I measure this out, I'm going to call that side 3. I'm going to write a little note on the side. And this side was 2.8. And so now this side again should be the same as that first one, which is going to be 3, and this is going to be 2.8 on this side. Again, my two bottoms here are going to be the same, and my two sides here are going to be the same. So if I were to add these up, 2 and 2 is 4, 3 is 7, 3 is 10. 0.8 and 0.8 is 1.6. So the perimeter is going to equal 11.6 centimeters. And again, I did that by using my ruler to measure the outside. Let's try this one on this side. So if I were to measure this guy, say he's about 3 there, so right on the outside. Measure this side, which is going to be 3 on that side. And so I know that on this one, if I were to measure it, should be about the same. And actually it's about 2.8. I think I said 3 earlier. 2.8 there. And this side, again, is 3. So 3 plus 3 is 6. 8, 10. The perimeter is going to be 11.6 centimeters. So in this case, when I used my ruler to measure out, I actually ended up with the same perimeter for those two parallelograms. Again, that was for my conjecture. Now, we only used 2 examples. Something you can try is to draw a couple of different types of parallelograms with the same base and the same height. Are we always going to get the same area? Are we always going to get the same perimeter? Continue to try some examples at home and see what you come up with when working with these types of parallelograms with specific constraints. Thank you for tuning in to Mr. Laner's Math Extravaganza. As always, we'll see you next time.